So I'm pleased to introduce you to the session Smarter RAG Pipeline Scanning Search with Milvus and Feast with our guest speaker Francisco today. He's a senior principal engineer at Red Hat, having spent over a decade working in AI and ML, also software, fintech, and AIG. The Commonwealth Bank of Australia, Goldman Sachs, Fast, Firm, and Red Hat in roles spanning from software to data engineering, credit fraud, data science, and machine learning. He holds a graduate degrees in economics and statistics and data science and machine learning from Columbia University in the city of New York and also Clemson University. He's a maintainer for Feast, the open source feature store, and a steering committee member for Kubeflow, which is the open source ecosystem of Kubernetes for components for AI and ML. Francisco, the stage is yours. You may take over.
Hi, everybody. I'm Francisco. Pleasure to meet you. See you. I'm going to take off my hat, but just for consistency of my profile photo on the webinar, I figured I'd show up with it. Today we're going to talk about Feast, RAG, and Milvus, and I am going to share my screen. Can folks in the chat let me know? Okay, perfect. Confirmed. Great. So let's get the party started. Feast, RAG, and Milvus, that's what we're going to talk about. So I thought I'd tell folks a little bit about me. I think it was already covered, but I wanted to give a little bit of context. I've led data science, data engineering, ML infra teams at different companies over the last 12 plus years. And somehow I stumbled into maintaining Feast. We shipped it at a previous company I worked at, scaled it in production for checkout payments, for credit risk and fraud models, where low latency retrieval is a really, really important part, and high resiliency and uptime. And so I kind of spent my career building models and then shipping models, and that heavily relies on data. And so again, that's kind of how I stumbled into Feast. I did things the old way before, and then eventually we have kind of newer, more structured way of serving models. I joined Red Hat last year, almost to the day, to work on open source AI, and I feel very privileged to get to work on Feast and Kubeflow and other communities, really helping to work on making sure that AI is open and using the best of open source. I have a wife and 2 children, and I call New Jersey home. I took this photo when I was in South Dakota. I used to live out west. It was a great time. I love it. Out in Rapid City, near Wyoming. And that's me. So let's see. So I wanted to start with some historical context, right? RAG is pretty popular, but oftentimes people haven't read the original paper or aren't aware about the original paper. And so I thought I'd give that brief history and context. And so RAG stands for Retrieval Augmented Generation. This is a paper published in NeurIPS in 2020 by the Meta AI research team, or back then it was called FAIR, Facebook AI Research. Looks like I missed a part of the finishing this bullet point in the second one. Anyways, the architecture talked about some things that people kind of omit today. They actually had 2 models at play. They had what's called a retriever in the diagram that I took a screenshot from in the paper, and the generator. And there's a query encoder as a part of this retriever thing, which is, we're all pretty familiar with like encoders, which take like a query or a sentence and then maps it into a vector, right? A set of numbers and like some varying length, which is set by the whatever model you choose. People tend to arbitrarily set some large number like 584 or something, usually a power of 2. But one of the things that was often missed in the dialogue about this is that when this seminal paper came out, it was about the end-to-end back propagation of the retriever and the generator. And what does that mean? That means that they took some sort of model, some pre-trained weights, and then they fine-tuned them. And I think that's really important, grounding layer, because that's really not how people think about RAG in practice today and how people use it. They mostly think about it from inference perspective. And that makes sense. You know, it's not a criticism, it's just kind of a statement of fact. And then, you know, so 2020, that's a while. You know, why did it become so popular? And if you look at some data, probably because of ChatGPT. ChatGPT, you know, disrupted the world in October 2022. They had, in their original documentation, they had suggested using RAG. And phrasing like in-context learning wasn't as common. But what people found was if you just dump stuff into the context of an LLM, it would work pretty well with some prompt instruction formatting, right? And if you look at the Google Trends, which I screenshotted both here, you know, again, December 2020 is when it was published, and you see that like it has pretty much no mention, but you'll see that when ChatGPT took off in October of 2020, that's when you see RAG really start to be popular, or at least according to Google Trends. And again, it's because they had sourced it in their documentation. And you know, I was working on some of this stuff back when that happened, and you know, used the OpenAI's demo that they, you know, showed you how to do it. And you know, it was surprisingly powerful and that's kind of like taken the mind share of what we call AI engineering today. But again, there's a really critical step that's like, I feel like it's missing from the conversation here, which is most RAG applications are only using inference, which is great, you know, given that it works, but it's also important to note that there was this whole other story with RAG. And I think a lot of it is because it's very easy to dump and format data and documents into the context and do vector similarity search, but it's actually a lot harder to do fine tuning. That's just kind of I don't think a controversial statement. So how does RAG work? For those who are unfamiliar, I thought I'd, you know, go through a simple example, which, you know, there are really 4 core steps, which is 1, you embed data, like maybe you take a document, PDFs, or just like some tokens, some like a blog, and you embed it, right? Again, map it into some vector space of all of the sentences. So you find a way to partition or chunk the text, and then you take those partitions, and each partition visually you embed. Then you store those embeds with some primary identifier into some database. And then, you know, in real time, you embed what's called the user query, which is like, I'm going to talk to a chatbot. I'm going to say, what's, you know, the capital of the US, right? And it's going, in real time, you'll also embed that query into a vector, and you'll use that vector to search everything in the database. And so vector search and Pinecone and Milvus arose to really say, hey, look, we actually support vector similarity search, and these things became very, very prolific and popular. And you know, Milvus had been around quite a bit longer, right? And earlier than really 2022, right? And I think it's important to note that vector similarity search as a construct has been around for a very long time, and information retrieval has been, you know, practiced for quite a bit. You know, standard you know, retrieval and recommender systems have been using this for quite a long time, which my understanding is that's actually how Milvus originally started. And so, you know, at the end, you get this query and you retrieve it with vector similarity search, and then you inject that into the context and go on your merry way and have your LLM generate some sort of response, and you hope it works. And in practice, it worked pretty well. So how can Feast help with RAG? I think, you know, Feast was really grounded as a feature store, and a feature store was really aimed at helping reduce the complexity in taking models, particularly tabular ones, to production. And it turns out that the hardest part about shipping models to production in the tabular predictive ML world isn't really the model itself. Actually, when models are small, inference reduces to really just being a calculator in real time. And And that's not hard. It's actually what's hard is orchestrating data. And that was those, kind of, I mentioned at the early part of my talk. What I found working with these enterprises is that you have so many disparate databases, data systems, that finding a way to centralize all of the data that you have so that you can then like featureize that data and then serve it to a model is actually quite hard, both technically and organizationally. And so, I've worked at places that implement their own crude forms of feature stores for most of my career until I ended up maintaining one. And there's a joke I like to tell about experience I had when I was at the Commonwealth Bank of Australia, where I flew to Sydney twice to get data from somebody. And it's actually a true story because it wasn't as obvious or trivial to actually get that data. And so it's a real problem for enterprise. And Feast aims to solve that by providing a centralized platform that stitches together your existing infrastructure and enables you to be successful in shipping models to production with the right patterns and permission and governance and server and everything else. And so the premise is Feast helps with RAG by empowering MLEs to do what they do best, which is harness the power of data. MLEs and data scientists, there's ambiguity about what the nuances between the two are, but I'll treat them as equivalent. And so with Feast, it's kind of easier to ship RAG to production. Feast is battle tested to support real-time batch and streaming data. As I mentioned before, at my last role, we shipped streaming, we shipped real-time, we shipped batch data sets of inserting sizes like 360 million records, and Feast scaled. I mean, you start to hit, really scaling this with the database that you're using is really what it reduces to. But we actually had great uptime using Feast, and so I think it works, and it's been worked by it works and it's used by lots and lots of great and powerful enterprises, and so we're quite proud of that. And so we're a little bit slow on getting RAG fully featured, but now we're at a good place with it. And so it's really built for distributed computing and ingestion. And I think I mentioned the insertion, but Spark support in Feast is a really powerful mechanism. It was donated by the Adyen folks, so I want to give a big shout out to them as the offline store. And the complication that comes up in generating training data for fine tuning is often, well, how do you embed like 1 million documents for training data, right? And then you start to use, like distributed computing frameworks, particularly like Spark or Ray. There are others like Dask. We also do use Dask, but we don't really use it that much for the offline store as much. But these frameworks exist, and ultimately they're built within Feast. And so we treat fine tuning as a first-class citizen, and point in time correctness, joining data, making sure that you're not what's called you don't have data leakage, which is looking at data into the future. And so these are all mechanisms of why Feast is really helpful with RAG, and it's fully open source, right? That's one of the really great benefits of it. That's why users tend to adopt Feast, is because they don't want to send their data outside, or they just want to control the service, and so that ends up being really helpful. See, so Feast in production. I wanted to kind of go over what the architecture looks like and how things look like in Feast, and how that kind of naturally follows with RAG. So in Feast world, there's two things. There's online infrastructure, which we call an online store, which is basically just a database that you'd use in like a consumer-facing application that has high resiliency and high uptime, and an offline infrastructure, which is like a database that you use for model fine-tuning, like an offline warehouse, where you're doing lots of reads, not tons of writes, and you're mostly like querying stuff like in BigQuery or Snowflake or Spark, on data that's not going to be like, if it goes down, it's not going to hurt your customers, basically. So if you look at the diagram on the right, we have what we call a data producer. And so what a data producer is basically like an application. Maybe you're a payments company and you have like an authentication service, right? Like a customer logs in and you want to keep their track of their session. how many times they've like logged in. Maybe it's about their payments, how many payments they've made in the past, if you're an e-commerce company, or products that they've purchased. What you would want to do is essentially that data, you might want to emit events or write data to an offline store so that you could go back later and analyze it. And like I said, without impacting any customer experiences. And this is pretty common, right? And like all business analytics is grounded in like some sort of offline analytics store, like ClickHouse or something, where it's like, I'm going to query this data and learn something from it. And then you get to the extent next of like, well, I have an AI engineer who wants to, an ML engineer who wants to build a model to predict something like, what a customer's, LTV is, or if they're willing to buy this thing, or build a recommendation engine. And that's what kind of the diagram on the very left, where the offline log CDC ELT. This is about essentially emitting data to an offline store so that you can then analyze it. And you get into this offline store, and oftentimes people just emit that to like an S3 bucket. Some people will do actually emit events to Kinesis or Kafka, and those end up, you can use an S3 bucket as well. CDC is change data capture, and so if you have like ELT systems, this tends to be a pretty common thing. Fivetran is an example of a provider that does that pretty well. There's Airbyte that I believe is the open source version. And so from that like emitted log data, usually that's where you generate training data sets. And Feast can nicely couple with things like Spark or Snowflake or whomever your offline store is, and help you create training data sets. That's really what its kind of big value proposition is there. It has data preparation, model training, and back testing that you might want to do within that like batch world where it's large computations on lots of data sets that will take a bit. And then there's this, and that's all going to stay within this data warehouse, this offline store land, really model exploration. And in the Qflow ecosystem, we talk about this like the model development lifecycle, and you'll generally stay in the offline store there. Now, moving back up into the diagram where we talk about the event hitting this kind of streaming application, Flink or Spark, for architectural reasons, some applications might want to actually use a streaming architecture or event-driven architecture where they're just going to emit events to a Kafka topic. And then consumers will subscribe to, or applications will subscribe to that topic and consume those events and process them on whatever cadence they want. And so Flink and Spark streaming are naturally good options in that case, where you can actually build transformations that manage the throughput that allows you to batch requests together and featured computations, so that you're not writing to the online store at too high of a frequency, because then you start to get to some resource contentions, and depending on if you get lots of volume all at once, you can actually end up incurring some challenges in production. And so some data producers, they choose a model where I have a sidecar, I'm writing events to an S3 bucket, or maybe they want to just instead of a sidecar, use Kafka, right? And then some people just do like batch dumps, right? Like every 24 hours, I'm going to take a copy of the database and just dump it. And then you might also want an architecture where that data producer, that application or service, I'm going to write directly to the online store via API. And Feast supports all of these architectures. And there are different trade-offs with these different write patterns, particularly for mission critical services, like in payments, like in lending, where you have different guarantees about the staleness or consistency, is the language that's often used, of the data. You'll want different write patterns to the online store for different data sources. Because again, they'll have different consequences to your consumer experience. And the most concrete example is that you want strong consistency if you're doing like lending, and you want to check out, or you want to create a feature to calculate someone's total exposure, i.e. how much money you've lent them. You don't want to get that wrong in real time. You want to make sure that like that number is calculated with the most accurate data, because that can have pretty severe financial consequences. And then once you kind of hydrate this online store with the data that you need from all of your different places, again, batch, maybe a streaming producer, maybe an online application, um, and centralize it into this online store for serving. Um, then in your AI application, you can actually talk with your inference provider. Maybe it's a separate service. Sometimes models are so small you could actually include them in your feature server. Again, for the tabular domain where models aren't super huge, that actually isn't an uncommon pattern. But there's lots of utility in having explicit separate inference endpoint, especially as models start to scale to really large. Any LLM naturally needs its own inference provider. And you see the kind of client AI application here where it could be a user's front-end browser, it could be another back-end service, all talking with these things. And in practice for large enterprises, this ends up pretty common pattern. And so you'll look at this and it's kind of abstract, but you'll notice that, well, this naturally applies for RAG systems, right? Because if you're taking documents, for example, maybe it's content from the web, from your CMS, right? Like Contently, where they have API, they have webhooks where you can, update, and you have changes happening to content, and you want to embed and reflect in your RAG system these changes, right? Well, you kind of have to do that with an API. If you do that in batch, you're going to have bad results in your retrieval because you'll have stale, unindexed data. And so everything kind of logically starts to follow, like, oh, actually, these data patterns are well suited for RAG. And it's not an accident. It's just only thing really different is just that it's text instead of tabular. It's still numbers because it's vectors, right? But it's an important part. And the real key value proposition here is that Feast treats not only the online infrastructure as a core priority, but also the offline. Again, it's fine-tuning as a first-class citizen. It's really the reason that Feast was originally built was to, reduce the kind of training and serving skew. There's an old paper called about ML ops, and this paper talked about the core importance of really the operation side of ML, and it's true for AI engineering as well and generative AI, because you have to still handle all of the same problems. You don't have to train the model often. Maybe you want to fine tune it, but all the other problems are still there. Data lineage, permissions, governance, reconciliation, and all this other stuff. And so, one of the benefits you get from Feast is this registry where it stores metadata about the kind of data that you use during, inference and training even. And so we'll talk a little bit more about that in a second. Cool. So I want to give a demo today, and I'm going to talk about Feast, Milvus, and Docling. So Docling is really cool. It essentially takes a bunch of different input types of text formats, whether PDF, PowerPoint, DocX, HTML, and it transforms it and embeds it into tokens. It embeds it into vectors, and it allows you to then upload it into Milvus. And so I created the simple diagram where you could imagine some admin, probably not an end user, chooses to write documents and ingest them into a feature store, right? And we'll just go with this really simply and do a batch exercise. You write them into the online store, and some user is going to want to retrieve them to talk to the docs. And that's basically it. That's the entire goal of this demo, is to kind of highlight how that works. And I just finished it this week, so apologies if I encounter any bugs. Bear warning. But this is kind of core of what Feast does. It ingests data, transforms data, and stores it. And it makes it available for low latency retrieval. Anything else is really beyond the scope, but that's what we aim to do. So let's talk a little bit about some of the Feast constructs that you're going to get here. So I wanted to go over Feast objects. So on the right here, you're going to see two snippets of code. The first one are entities. So we call it chunk ID here, and there's a value type. It's a string. It's basically to say, it's a Feast construct, and the entity pretty much maps to a primary key that you're going to put in a table. And this document is another primary key that you're going to put into a table. And there's some stuff there that ends up being useful for Feast: the description, the value type, and the join keys, because you can have multiple join keys in one, and so that's why it's a list. There's data sources that you declare. And these are like files and request objects, which is like a CSV or a Parquet file, and then an API call. A request object allows you to send like arbitrary data to Feast, and it'll treat it as just like an API call and allow you to transform it and do stuff with it. And you'll see the source right here is this file source, and it's the Parquet format, like I said. And then there's the request source, which in this case it's going to be a PDF, and you'll see there's PDF bytes. And so what that means is that we're going to cast the PDF into bytes. We'll load it in Python and send that. And then the file name, which is a string. And so I define all of that metadata so that I can then define what's like a logical table, which is the feature view on the right. And so the feature view is called the Docling example feature view. Very creative name, I know. That variable with the name of Docling feature view, and it has the entities, a list there. It's just defined as chunk, and the field name is filed name. So there's a field definition. Field equivalent to like a feature. Feature as language is very common among ML engineers. It's not as evident to all other people who don't build models, but the common nomenclature there is features. We call it fields here just to be explicit that it's a field, that this is a schema for a field that ultimately maps to a database table. In Milvus, it's a collection. And here you'll notice that there's this raw chunk of markdown. So in Docling, you can extract partitions of the text of the chunks, and here I'm just extracting them as markdown, and you'll see that code in a second. And you'll notice that under the vector field, there are two additional booleans beyond the D type, which is an array of float 64, which is a vector index. And you see how it says true. That's how you configure vector similarity search in Feast. And the vector search metric is cosine, so that's distance metric that's used to calculate. So what I want to emphasize is a lot of hard work to make this thing happen, but I'm really excited about it because that means that ML engineers, they don't have to care. They can just declare this feature view and then tell their software engineers like, hey, look, just use this. It's easy. And then they can serve their ML models and their LLMs and customize it to their needs. And so that's kind of really the exciting and powerful part. And you'll see that you also source the data source there. And that ends up being important for materialization or actually data ingestion later on. There's a TTL, and that's basically it. We have our metadata. Now, I want to talk about how we extend this, which is how do we do transformation? And Feast allows for feature transformation in batch compute engines like Spark, as I mentioned, streaming compute engines like Spark Streaming and Flink, and then the API servers, which is the Feast feature server. And the way that that's done is through a decorator, and this defines basically the other stuff that you just saw in the feature view. And then within the function definition, that's where you actually define like the transformation. Now we're actually going to revisit and change this a little bit to make it a little bit easier for engineers, but it'll be the same sort of structure. We're going to rename the decorator from on-demand feature view to transform, and then everything else stays the same basically. And it'll be backwards compatible, but it is meant to provide some clarity to people. But here, this is the Docling transformation. So what happens here is if you send this function an arbitrary set of PDF bytes, it's going to extract the text from it and embed it. And so you'll see that there's this list of objects that you initialize, and then it just appends them. And it appends the document ID, the chunk ID, which we generate as just linearly chunk 1, 2, 3, 4 to n. And then the embeddings, each embedding is of length, like I think 584 or something, I forget. Or maybe it was 384, again, I forget. And then the actual chunk text. So all that is in there, and it's all just declared here. And so this the thing I really want to clarify is here is like this, let's say 50 lines of code or so allows you to ship RAG with Feast. Obviously, there's a lot of infrastructure code that has to be written to deploy this stuff, right? But once that, you empower your ML engineers to really start to ship RAG solutions left and right and serve them in production systems, and even scale them. And that there's more discussed there. And so the data ingestion or document ingestion, it's simple. There's an API endpoint. There's a push and write to online store and materialize. Materialize is meant for batch. Push and write to online store are meant for API, where you actually want to hit in live services, and materialize lets you take like batch data sets like CSVs to do it. And that's it. So you get that kind of free. Yeah. And this is the API docs that out of the feature server, you get your open API docs available, which is nice. And you see the get online features, retrieve online documents, write to online store. There's a health check. And we recently added this chat UI that allows you to kind of like, ML engineers to quickly get up and running, writing some RAG systems. And so I'm going to go into the demo now before I get into the roadmap. So apologies. I'm going to stop sharing. So let's see, we're gonna do this live, see if it goes well. And if not, I'll just share the notebook. Okay, so this is the command line. Can people see it? No, or am I sharing?
You can share your terminal now.
Okay, people are seeing my terminal? Yes?
Yeah.
Okay, cool. So you'll see this is the fee structure. There's some pickle object. Oh, I see. So there's this feature store YAML file, where here it's just going to have a project name, a provider. Here it's going to run locally using Milvus Lite and the online store. And the embedding is 384, and the index type is flat. This entity key serialization is an implementation deal. You don't have to work. We support authentication, OIDC, and so there's some of that stuff you don't have to worry about is documented. So I invite you to look at documentation if you care. But it's basically where you define your configurations, right? And then we can look at this example repo to go through the stuff I just mentioned, which is all of the things I had mentioned. Here, we're defining the embedding model, the maximum number of tokens. This is the tokenizer embedding model sends this transformer, this chunker. This is embedding the text actually. This is generating some chunk ID. I already walked you through all that stuff. Again, this is there's those transformations. And so there are a couple commands you write in Feast to do this, and you say Feast apply. This is going to register the metadata. Let's see if it works. Ignore the warnings. Let's pretend that they're fine. Let's see. This is all Docling stuff. So applying changes for project RAG. See, this is actually what we should be used to seeing. And there we see infrastructure for Docling feature view. The one we talked about. This is essentially a batch feature view. And so let's see. So we're going to look at this test workflow script, which is going to show the demo. And so what's going to happen here is I'm going to read this document data. I'm going to actually apply this transform feature view, the one that's actually going to transform things on the fly. Just as an example, there's a bug there that we have to work through, but that's fine. And I'm going to log the different types of embeddings that are materialized or uploaded to this database, to Milvus. And then in this one, we're doing the same thing, except now with a different feature view. This is the one that's writing the raw text itself. And what's going to happen is it's going to transform it on the fly. So that'll be kind of neat to see. And then we're going to ask a question and then retrieve online documents for RAG, top K. And then we're going to print it out. And then there's entity-based retrieval, which is, showing this part. Oh, sorry. This is then retrieving the same from the transformed versions, where you're just going to send in a query embedding. So I'm doing retrieval of the batch one and the transform one, and you get the same, right? It was just kind of showing that they're equivalent. But one, you get to kind of transform on the fly like you would be an API, because that's exactly what you want to do in live production settings. And this one is, again, the entity retrieval. And so let's give it a try and see if it worked. Test workflow. Please don't make me regret it. I tested this like an hour ago and it worked, so let's hope. The problem is it takes a minute because transforming the PDFs during ingest, yeah, writing the pre-computed values, okay, and then transforming, okay, it's doing something. I should have picked smaller data as the conclusion. I probably should put a progress bar too. That would be useful.
Yeah, welcome to when it's awkward and you just have to wait, until it's done.
I didn't, when I was doing this demo, I didn't think, I was like, it's working. Like, the little stick figure walking across the terminal would have been good. That's
But maybe I'll quickly hijack that. Do people have some question that they want to ask at the end? Feel free to ask them as well directly in the chat. So we can
yeah.
ask them.
Yeah, if folks have questions, do feel free to ask. Happy to maybe the terminal is cropped. No, it's there. It's just it is doing some calculations. And so what's happening is that actually the Docling, and what's really cool about Docling, and I invite you to read more about it, is that it's running computer vision and small LLMs during transformation. So it's taking this PDF and basically extracting the text, right? But how does it do that? It also extracts graphs and adds that as textual metadata. And so it's doing all that. So it's actually quite computationally expensive, and it takes a couple minutes, in fact. So I forgot that it usually takes me a while to do that. And we're gonna end up sitting here for 5 minutes.
And by the way, are you happy with the error that you have, or is it
Yes,
okay?
yes.
Okay.
Yeah, it's fine. Token indices length is longer than the specified. Yeah, that's not a big deal. It takes nothing away from the example. Yeah.
And Docling is, just because I actually didn't know about it before, it's like fully open source, and then
Fully open source. So this was a project created by IBM,
okay.
IBM Research, and they recently donated to the LFAI Foundation.
Okay.
So it's fully open source, open governance, and I think it's a really great tool. We added it to Feast, the feature server, specifically have like, an open source parsing tool so that data scientists and ML engineers can be unblocked without having to really deal with figuring out like, well, how can I take my PDFs and extract them, right? We know how to do that with regular text, and oftentimes that's how data comes, but that's not the only thing.
And does it support like different? So it supports PDF, but also does it support like different formats and stuff?
It does. It supports a lot of really rich formats, and again, it's yeah. So there you go. So it worked.
Let's go. I'll take you over. I'll let you take over.
Yeah. Thank goodness. Oh, there's an issue with the retrieval, but this part, but that's fine. That's just a bug. So here, what you'll see is that the Docling features. We passed in the first, and actually, let me go and look at the code, and I'll show you, right? The query embedding that we showed was, here it is. What's the name of this paper? That's the question we asked. And references here. And so they both showed the same thing. And because, again, this one was like this batch transformed and just uploaded. And this one was the one that was transformed on the fly. And the reason it took so long is because it was iterating. I think it's 10 PDFs that I was processing. I should have just done one for this example, so my bad. But it went and chunked them and embedded them. And this is the example. You know, we ask the question and it gives us a whole bunch of references of like articles that are named. And so it works, it does the thing. Now the thing that we're really excited about with this and you know, things that we intend to enhance is making this, again, just really exceptionally easy for ML engineers, people to ship production RAG applications that can really scale. And so I'm going to get into that in a little bit more in a second after I share my screen again. Yes, let me share here. Yes, we talked about ingestion. And so the roadmap of Feast, what are we doing next? More NLP. You know, again, we want Feast to be the go-to framework for AI users to customize their RAG solutions. And that means investing more in Milvus. Milvus, you know, again, is an extraordinary database. You know, it has a great inline behavior or local behavior with PyMilvus Lite or Milvus Lite that just makes it really easy for end users to get up and running. And I think that's really important. A lot of what I found when working or leading some of these teams is that if there's a lot of friction for data scientists or end users to get started, they just don't want to use it. And so in Feast, we've invested a lot into making that experience very good. And Milvus, you know, is one of our favorite frameworks because of that. Because of Milvus Lite, you know, you don't have to really think too much about containers or how to deploy it. You can just kind of hit pip install and go. And so that's one of the things that we really like about it. And again, we'll continue to invest a lot more in NLP. Image support. So, you know, images are interesting because they're actually pretty analogous or equivalent to language in the sense that you often want metadata. And this is one of the things that I think I understated in this talk is that Feast allows you to store additional information beyond just the sentences or the tokens, right? And it turns out there's a lot of rich structure that can be optimized for that. And if you actually work in recommender systems, you'll know. And like basically you can reduce RAG to being a recommender or rank and retrieving system. And there's a lot of really rich metadata that can be used to power this text in addition to just text itself. And by that, I mean like you can do what's basically like hybrid ranking, right? And you can rank different pieces of the text differently. And so if you have like the title, if you have like the age of the document, these are all things that you can use to weight differently. And you can even build a model on top called a re-ranker to fully optimize these things. And so that is an area that we do intend to allow customization for. And again, so that it can be fine-tuned, because you need to be able to fine-tune it so that in serving, you know what parameters are and which pieces of content and how you want to structure the data. And that becomes very hardly codified. It's not the same RAG of I'm just going to throw it into the context and see what works. It's actually much more optimized systems. And so I think both have to exist, and they both end up having to be very powerful. And as LMs get better, certainly that will get a little bit better. But my long view is that there's always going to be a need for fine-tuning some of these systems, especially once you hit real scale, where another 1 or 2% really makes a big financial impact. And so scaling batch, we already support Spark as an offline store, I mentioned that, and for batch transformations. We intend on incorporating Ray at a point in the future when other maintainers are pretty excited about doing that work. And then latency improvements. I spent some time optimizing a lot of the computation and retrieval latency within Feast in the past, and we continue to invest in that because we want Feast to really be blazing fast. You know, I used to work at a company called Fast for a reason. We like fast things. And so thank you. There's a Feast RAG blog post that talks a little bit more about what the value proposition of Feast supporting RAG and why I spend so much time on it. You know, I have a background in NLP, coincidentally, and so that, you know, when I became a Feast maintainer, in fact, that was the thing I said a year and a half ago that I would do, and you know, almost done it. Job's not finished, but we're getting close. There's some links to the Feast documentation, the Feast website, a GitHub repo with the demo, and the GitHub repo with the Docling demo. So there's one that's just focused on basic RAG with Milvus, And then there's another with, this Docling demo as well with Milvus. And so I want to say a big thank you to Stefan and the folks here at Milvus for inviting me to talk and share the gospel of Feast. And this is a generated image of a robot eating a bunch of rags, feasting on rags, if you will. I thought that was funny.
Thank you very much. And I think it's funny. Thank you very much for a very detailed presentation, actually. See, even people are laughing in the chat and it wrote in the chat, which means they really laughed. So
I think they're just being genuine.
do we have questions from people? So just quickly, otherwise you mentioned, I have one on my side, so I'll just start. You mentioned a couple of times, like low latency for Feast. What is it? What does it mean exactly? Like, what is your thing you're targeting usually? You would say, sorry.
Yeah, that's a really great question. I was imprecise and I should have been more precise. But like I think so if you're serving stuff online, usually at really high scale, you're going to say, well, what's my percentile distribution of latency, right? And so
Exactly.
typically people focus on P99 because P100 you're going to have a bad time. But like P99 is there, well, let's optimize for that. And depending on the data store and the indexing strategy, it ends up with different trade-offs. And I think for vector similarity search in particular, it's very hard because that scale is proportional to the number of documents being embedded and retrieved. And so like that, there are some bottlenecks that you're going to ultimately hit. So if you want like 100 docs, well, that's going to be a lot harder than like you're gonna hit some bottlenecks. But for basic entity retrieval, that we know really well. And so things like a Redis cache or Redis ends up being quite performant, where you can get P99s of 5 milliseconds.
Okay.
MySQL database you can get around 10 milliseconds P99. And there are ways to continue to optimize that, but really within the code itself, because like some of the things you get bottlenecked by just the database. Basically, you end up like the functional limit is how fast can the database retrieve from the database, and then you do that. And the strategy is one, having really efficient optimized code that isn't doing too much in the handling and serialization and deserialization and computation of the data on the fly. And then two, pre-computing. And so like a lot of what Feast really aims to do is pre-compute, and what our documentation talks about is pre-computing is the gold standard. If you want really good customer experiences, pre-compute as much as you can, which is why we invest in the batch. So a concrete example, you have 1 million documents that you want to be able to search through. You have to batch embed those. You have to embed them and upload them online to the degree feasible. Because if you try to do that on the fly every time, you'll see what we just experienced right in the terminal, where it's like it's going to take time. There's like you are bound by the calculations that you have to execute. Of course, we could have done them concurrently and made things slightly more efficient, but the fact is you have to pay that calculation tax. So pay it before your users come to your application if you can. That's not always feasible, right? If a user's uploading their own document to you, well, then you have to wait because you have to process it. You have it once. But if you have old documents that you want to upload and make accessible to every user, well, then you absolutely should have done that like way beforehand, and then uploaded it. So, but again, like at the Feast layer, we are going to continue to optimize our code base so that it's as lightweight and efficient as possible.
Thank you. And then I'll follow up with one is like, so you used like how would you customize like embedding models and chunking there directly? Do you do it on a like Docling level, or where does it work if you don't?
Docling has a really wide breadth of ability to actually customize, and so like I don't know the full extent of all those parameters in Docling, but they are documented and available, pun intended. And what I'd say is that if you're not falling within the subset of like, well, my data doesn't fit Docling, well, that's actually part of the point of Feast, is that whatever text data you have, if it's just text, this is what Feast is built is that you can choose to do whatever sentence transformer you want, whatever PyTorch code you want, whatever tokenization strategy you want. All that can be done because you have the toolkit to say, well, look, you can serve whatever you want. You can execute arbitrary functions. I don't recommend calling other APIs within feature transformations. Some people will do that, and that's fine. But like that's when you start to introduce latency, and you actually get more complicated systems. But ignoring that detail, the the flexibility of Feast is that ML engineers who tend to be very rich domain experts in how to outline these things can really kind of steer the wheel here.
Okay, and yeah, actually follow up just more like on a philosophical level, sorry. So your main users are ML engineers, what it was very popular a couple of years ago when I was myself an ML engineer. Do you see like how does it work now with the new AI engineers? Because they use a lot of, API calls and LLMs directly and stuff like how do you see the future with Feast and AI engineers and ML engineers?
Yeah, it's a really good question. I think like we're definitely like I love to cater to AI engineers. I really would. I think and like I obviously have to share
Ah,
Chip's
yeah.
book, AI Engineering. And in it, I talk about this a lot. She mentions that AI engineering emerged from ML engineering.
Yeah.
Real thing is you don't have to train a foundation model anymore. You can just treat it as an endpoint. But all of the, and she says this in her book, and I've quoted it in some internal papers I've written, all the other problems are still there. And Feast isn't about inference. Feast is about the data. So all of the Feast problems that we encounter, they exist. And other frameworks maybe don't have the 10 years of knowledge that and scars that we've developed in building these production systems. But it's a lot of those things are out of the box in Feast. But I think the challenge with Feast is that it's so anchored towards ML engineering language and jargon
Yeah.
that it doesn't necessarily immediately catch with like AI engineers. And so there's the marketing angle, like, hey, look, can we bridge that gap? I don't know if we ever can, but I do hope that we're able to continue to build and enable those folks to succeed as well. Yeah, I definitely like am welcome to. I think part of the reason I built out this Docling and the demos that we've done is to actually, go to AI engineers and say like, hey, look, if you want to do really, really sophisticated stuff, here's the path to it. But my high conviction bet is actually the amount of ML engineers is going to continue to increase because of more AI engineers. Because you start to find that like, oh, actually, I do want to churn all these cranks and I want to put on all these bells and whistles because that 2% now starts to be really valuable. And AI engineering really does unlock that. And so that's kind of where my view on it is. But there's a lot more of a upfront cost you have to pay with these things versus just like, you know, like calling an endpoint or something, right? Or just like using pandas to dump it into into something, right? Or face, right? Like all these things. And so I acknowledge that like it is more engineering challenges. That said, we do try to make it pretty easy for people to get started.
Cool. Well, thank you very much. I'll just wait, but yeah, hopefully otherwise you still get to have like a lot of AI engineers, a lot of people coming to using Feast. I was using it myself actually a couple of years ago, so it's nice to see that it's still here, fully alive and
Yeah,
getting.
we're working on it, man. It's
Yeah, okay. And yeah, again to everyone, so it was recorded. We will share it in a couple of days after it's been edited and stuff. So if you also want to send it to your friends, feel free to do so. I thought it was a wonderful presentation, so thank you very much, Francisco. And hopefully, I will get to see you one day, and hopefully, some people will get to use Feast as well and see how nice it is. Thank you. Thank you very much. Thank you, everyone, and have a lovely morning, afternoon, or evening, wherever you are in the world. See you.